So first of all, tell me, can you hear me clearly? My voice is clear. Okay. Uh, so today is our week 5, and we are going to discuss the vectors and vector spaces. So please wait a minute. I'm going to upload the PowerPoint slides. So today we are going to discuss a vector space. In this, we will discuss what are the vectors, and we are going to discuss what are row vectors, column vectors, zero vectors, and after we will define some linear dependence and independence. So these topics we will discuss today. So first of all, we will see what is the vector. So vector means an ordered n tuples. A sequence of n real numbers x1, x2, xn is called the vectors. So in R n space, it is, if we are denoted R to the power n, it means we are talking about the space. If I write R to the power 1, we say it is in one space. If I write R to the power 2, it means it is a two-dimension space. Tuple means this is tuple 1, tuple 2. These are the tuples. So these are written here. So if I write R to the power 3, it means it is a three-dimension space, third space. So n space means a set of all ordered in n tuples. And so and these are the tuples 1, 2, 3, 4. So for example, in one space, we are defining here in one space, we say that R1, we write it R1, one space, set of all real numbers. So yeah, like 1, 2, 3, 4, 5, 6. These are in one space. Similarly, if we are talking about R square means two spaces. So we most of the time we write R like in this way, uh, in this way, R square. So for differentiate different, it's little bit different from the real R. So here we write a little tilted R, so or in a bold manner. So it means we are talking about the second space. So any example of the second space? The example is set of all ordered pair of real numbers. Like here we can write x1 x2. So these are the we are it means we are talking about the second space. Similarly, if we are talking about R3 and three space, so any example, so set of all ordered triple in a real numbers, like if we are writing about x1, x2, x3, so these are in the three space. Similarly, for 3, 4, 5, 6, 7, 8 up to n space are there. So these are the notations. So an n tuple x1, x2, xn can be viewed uh, as a point in Rn with xi as a coordinate, and n tuple x1, x2 can be viewed as the vectors. So these are in a vector space. A point can be defined as like this, and a vector can be defined like this. These are the point, and this is a vector. So here there are two vectors are given, a vector u and a vector v. So vector can be defined, either we can define in a bold letter like u, or we can define in some books they can define like this vector, and in top of the vector they will put the arrow sign, so like this. So anyway you can define a vector. So in this PowerPoint slide they define the vector like a bold letter. So whenever there is a bold, it means that we are talking about the vector. And in some books, you will see the vectors here in some books. So in some letters, uh, in some letters, some books they write like this, any U bar and V bar. So, but we are talking about capital bold, capital V. So it says that the two vectors are equal if and only if the tuples, if their tuples are equal. Any U1 will be is equal to V1, U2 will be is equal to V2, and UN will be is equal to Vn. Now, what about vector addition? Vector addition means if you are going to add the two vectors, so it means that you have to add the corresponding elements. Similarly, if you are going to subtract, then you have to subtract the corresponding element. Yani you will subtract u1 minus v1, u2 minus v2, u3 minus vn, un minus vn. These are called the vector addition, and similarly vector subtraction, and the scalar multiplication. When you are going to multiply any constant, any scalar with the vector, then like this you have to multiply. The sum of two vectors and a scalar multiplication of a vector Rn is called the standard operation in Rn. So if you are going to multiply a minus 1 with any vector, what happens? Then every tuple we have to multiply with the minus 1. Similarly, the difference is like this, that I told you, like addition, like a subtraction. If you are going to add or you are going to subtract, then you have to add or you have to subtract every element, any corresponding element, and u1 to u2, u1 to u1, and u1 to v1, u2 to v2, and u3 to v3. Like this, you can add or you can subtract the vectors. Similarly, the next one is a zero vector. Zero vectors can be defined as like a zero, a capital letter, the capital bold letter, that is a zero vector defined like this. And in two space we can define like 0 0. In 3 space we can define like 0 0 0. In n space we can define like this. So 0 a vector is called the additive identity, and the vector minus is called the additive inverse. So you remember these things. We will use these things in a next week syllabus. We will use these things. 0 is called the additive identity, and negative -1 is called the additive inverse. Here it is -1. So -1 is called the additive inverse. So properties of the vector addition and scalar multiplication. So the properties of the vector addition in the scalar multiplication, there are several properties are given here. So he says that there are three vectors are given u, v, w. So and c with a scalar. So it hold u plus v is a vector space. It hold the commutative law. Is hold the associative law. It hold the existence of identity. It hold the existence of inverse, and we multiply with the constant. So these are the several rules are there, and these are the several rules are there. There are 10 rules are there. These are called the properties of the vector. These are the properties of the vector. So similarly, let's see some examples of the vector addition and multiplication. So it says that there are three vectors u, v, and w. There are three vectors in R4. So what you do, you have to find the value of x. What is the value of x in? There are two questions are there. Question number A and question number 2. So you have to find the value of x. So and the value of x will be equal to 2u minus 2 minus v plus 3w. So this is a very simple question. There is no need to do. Just for your understanding, we will solve this question. From this question, you understand how we can apply the operation. So first you write what's given, then put the value of u, v, w. Every vector, the value you put the value of u here, it is given, and the vector v value is given, you put here, and the vector w value here given, you put here, and multiply with 3. So there will be 2 to the 4 and 2 minus 2. So these are everything is written here, and after that you will subtract these three vectors. So when you are going to subtract, 4 minus 4 and plus 18. So I write 4 minus 4 plus 18 here. So in this way, similarly, -2 minus 3 and minus 6. So I write -2 minus 3 minus 6. So what it will be, if you are combining all them, you will get 18, and if you are combining all them, you will get this and this. So from this you can solve. So it's very simple now. For your convenience, for your understanding, this is an example. Hopefully you understand. Maybe there is nothing new in this. You have to understand. So similarly, another question. Question number B is, it says that 3x plus w is equal to 2u minus v plus x. So this is also the same question. You have to find the value of x. What is, so there are 2x, just multiply, just open this bracket, 3x is equal to 3w, and there is 1x. You take this x on the left side, and similarly just solve them. So let's see the same question on the next slide. Let's see. So here it is also just open this bracket, open the bracket, and take the x on the left side. So here we take the x on the left side, and whatever the rest of the element take on the right side. So 3x minus x will be is equal to 2x, and whatever the element here, it is here. Then x is equal to, just divide by 2, yani ke u minus 1 by 2v and 3 by 2 w. So this thing is complete. Now now put the values of u, v, w. You know what are the values of u, v, w? The value of u is there. You put from the question. The value of v you put here, and the value of w you put here. There is nothing new. Everything is now. What's the next thing? You will add all these things. So add the corresponding elements. 2 minus 2 plus 9. What it will be? If you are adding all these things, 2 minus 2 plus 9, that will be is equal to 9. Similarly, add 1 minus 3 by 2 minus 3. Just add all these things, you will get minus 11 by 2. Similarly, 5 1 1 minus 1 by 2 0, that will be is equal to 9 by 2. Just add, it's simple addition. 0 1 by 2 and minus 9 by 2, you will get minus 4. So that's very simple. So just add all these things, you will get this result. So these are what you say, Mr. Naman. Why don't we divide 2 from left with element? Yes, we already divide it. We already divide it. We did it. If you see this 2x, if you see this 2x is equal to 2u minus v plus 3 minus 3w. If you take u on the left side, so it will be 2 will take left side. So 2 by 2 will be is equal to 1. So here it is 1. And v by v by 2 I write here v by 2, and 3 by 2 it will be I write here 3 by 2. So I put the value of u here, and the value of v I write with that, with divided by 2. If you see the value of v, that is not 2 minus 3 by 2. It's not the value of v. Just see the back slide. The value of v is 431 minus 1. So when you divide it by 2, it will be 4 by 2 will be 2, and 3 by 2 will be 3 by 2, and 1 by 2 will be 1 by 2, and minus 1 by 2 will be minus 1 by 2. So let's see in the what happened in the next slide. So this is okay. So this is the value of, I already divided. Okay. So after that, you will add all these things. You will get the result. So hopefully you understand the addition and subtraction of the vectors. Yani we will add, we will subtract with the corresponding elements. This is the one thing that we want. I want to say you. So hopefully you understand the addition, multiplication, and subtraction of the vectors. Okay. Okay. So let's proceed. Properties of additive identity and additive inverse. So let V be a vector in Rn and C be a scalar. Then the following is true: the additive identity is unique. So this is the additive, and the additive inverse of the unique is u plus v is equal to 0, u is equal to minus v. So these are several theorems are there. Next one is linear combination. A linear combination means whenever a vector x is called a linear combination of v1, v2, vn, it can be expressed in the form of x is equal to c1, v1, c2, v2, and cn, vn. Then we say that it is a linear combination of this. So for more detail, we will discuss linear combination in the next week. But I'm giving you a little bit idea about the linear combination. It says that whenever we write x is equal to c1 v1, c2 v2, c3 v3, cn vn, we say that it is a linear combination. So, for example, we have given a vectors x is equal to minus 1, minus 2, minus 2, and u is equal to 0, 1, 4, and v is equal to, there are three vectors are 3 and 4, yani u, v, w, and x, the vectors are given, and you have to ask the value, find the value of a, b, and c, so that x is equal to a u plus b v plus c w. If these things happen, find the value of x. So what you write, you will write, first of all you will write the value in the form of the equation. Like first equation will be 0 minus 1b, 0 0, and then uv, then 1 minus that will be uh, 3 3 and minus 1. Yes, first of all you write 0, then minus 1, and 3 will be is equal to minus 1. First of all you write the elements on the x. This is the first element equation. Now you write the second equation, that is 1, then 1b, and then 1c. So you write the second equation of the second element. Then for the third element, 4a, 2b, and 2c is equal to minus 2. So this is the third equation for the third element. So when you solve these three equations and three unknown a, b, c, so you will find the value of a is equal to 1, b is equal to minus 2, and c is equal to minus 1. So you put these value in this equation. In this equation, put these values. A is equal to 1, b is equal to minus 2, and c is equal to minus 1. So when you put these value, you will get x is equal to u minus 2v minus w. This is called the linear combination. Now, again, we are going to discuss a linear combination. We are going to discuss the vector. So it says that a vector can be defined by a row vector or a column vector. So row vector can be defined like if we are putting in a row, so we say that it is a row vector. If we write in a column, then we say that it is a column vector. So the matrix operation, addition, and scalar multiplication give the same results from the corresponding operation. So these are the some more definition in a row vector and column vectors. So again, we are going to discuss the vector addition and scalar multiplication. So if we are going to add the two vectors, again we are discussing, so we will add the corresponding elements, u1 plus v1, then u2 plus v2, un plus v1. It is already we defined, again it is defining. And similarly, if you are multiply with any constant with the vector, then every element we have to multiply c1, cu1, c2, cu1. Similarly, if we have a column vectors and we are going to add the column vectors, so the same procedure, there is no any change. We will add first element to first element, that is u1, v1, second element to second element, u2, v2, and all these things. Similarly, if we have a column vectors, we will multiply any constant with the column, then there is no change, the same procedure, just it is multiply every element with the column. So already we discussed these things, there is nothing new. So there is a vector space. Vector space is, it says that a vector, let V be a vector, let V be a set on which two operations, vector addition and scalar multiplication, are defined if the following axioms are satisfied for every u, v, and w. V is a scalar, real numbers. So it says that whenever we will satisfy all these properties, yani addition, commutative law hold, associative law hold, existence of identity, existence of inverse, these properties are hold. These 10 properties are hold. These are its multiplication properties, and so whenever these 10 properties are hold, we say that it is a vector space. So these these 10 properties we have to remember. So more clearly you will study in the next week what are the vector space. But right now I'm giving you just a little bit idea of the vector space. So these are the 10 properties, 10 points, or you can say 10 axioms are there. So we if any vector space it follow the 10 axioms, then it means that it is a vector space. If it is not followed these 10 axioms, then we say that it is not a vector space. So we denote it like v plus and multiplication. Vector space can be defined like v plus and multiplication. In this way, we will define it is a vector space. So 0 is a vector space. Properties of scalar multiplication, it is defining here with the 0. So there are some examples there to show that a set is not a vector space. You need only find one axiom that is not satisfied. So we have it saying the note says that if you have asked the question whether to check whether it is a vector space or not, so you have to check all the 10 properties. If any one property is not hold, then you say that it is not a vector space. So all the 10 properties, that is, it's hold the commutative law, it's hold the associative law, it's hold the existence of identity, it's hold the existence of inverse. So all the 10 property you have to check. If any one property is not belongs, then you say that it is not belongs to a vector space. So we see there is a question. It says that a set of all integers is not a vector space. So we check we check all the properties. It hold the commutative law. Yes, it hold the commutative law. It hold the associative law. It hold the existence of identity. But there is one law. It is not satisfying. So the one law is if we take, let us, one belongs to a vector space and 1 by 2 belongs to any real number. So when we multiply 1 by 2 with the integer, any one, this is a vector and this is a scalar. When we multiply 1 by 2 with 1, that we get a 1 by 2. That is a non-integer. 1 by 2 is not an integer. It is irrational. So it is not belong to vector space. So it means our scalar multiplication, uh, axiom 8 is not satisfied. So we say that it is not closed under scalar multiplication. That is why we say that it is not a vector space. Similarly, the other example is said that the set of all second degree polynomial is not a vector space. So again, we will check all the 10 properties. It holds the commutative law, associative law, existence of identity, existence of inverse. So, but add when you check just first law, that is when you are adding the two vectors, so px plus qx, so x square minus x square will, when you are getting x plus 1, it is not a second degree, it is 1 degree. It is not a second degree, it is 1 degree. So it means it is not belongs to a vector space. Scalar means there is a constant, yani 1, 2, 3, 4. These are all scalars. And vector means yani we are the vectors, and scalar means whatever the constants are there. These are called the scalars. So this means these are not the vector space. So similarly, there is a subspace. So wait a minute. So wait a minute. So this means it is not a vector space. So similarly, next thing is a subspace of a vector space. Subspace means whenever we talk about the subspace, yani, if we have a space and there is any subspace in this, so we say that if it is A, it is a subspace of B. So it means A is hold all the properties of B. If B is a space, vector space, then A is also a subspace of B, and A holds all the properties of B. So subspace means we will define like V plus dot is a vector space. Then for the subspace, it has to show that W is not empty. It must be some element, and W contains in V. So we define a subspace W plus dot is a vector space under the operation of addition and scalar multiplication defined in V. So whenever we have to define a subspace, we will show these two properties. If these two properties are whole, then we say that it is a subspace. If these two properties are not solved, then we say it is not a subspace. The two property says that if U and V are in W, then U plus V in W. And addition is also hold. And the second property is if U is in W, C is in a scalar, then if we multiply with this U, it is also in W. So whenever these two properties are whole, then we say that it is a subspace. Yani addition and scalar multiplication. These two properties are for the subspace. So let us see the examples. The example is says that let W be the set of the singular matrix of order 2. Show that W is not a subspace of M22 with a standard operation. So as I told you, to show the subspace, we have to show two things. One thing we will show it is it has a addition. It holds the addition property. Yani A plus B also belongs to W. First of all, it also belongs to W. And the second property, it must be whole. Yani C into, if we multiply any vector, it is also belongs to V. So these two properties are hold as I showed you in the previous, this C into U. And U plus V belongs to W and C into U belongs to W. So let us see in the example. So it says that we take a two matrix. A matrix A belongs to W and a matrix B belongs to W. So these are two matrices. So let us check the first property. So first property, let us check if we are going to add A plus B. So 1 plus 0 will be 1 0 plus 0 will be 0, and 0 plus 0 will be 0, and 0 plus 1 will be 1. So when we are going to add A plus B, we get the matrix 1 0 0 1. It is not belongs to W. So it is not belongs to W. It means that W2 is not a subspace because of our theorem. If the addition or scalar multiplication anyone is not belongs to W, then we say that it is not a subspace. So here our first property is not whole, then we directly say that it is not a subspace. Similarly, let us see one more question. Here it says the question show that x w is equal to x1 x2, x1 is greater than 0, x2 is greater than 0 with the standard operations is not a subspace in R square. So first of all we check the addition. So addition properties is whole. So let us check the another property, that is scalar multiplication. So he says we take u is equal to 1, 1 belongs to W. So if we multiply minus 1 with the u, then minus 1 with multiplication 1 into 1, then minus 1 into minus 1, that is not belongs to W. So it means the scalar, it is not closed under the scalar multiplication. The second property is not hold here. So that is why we say that it is not a subspace. So whenever we have to check whether it is a subspace or not, we have to check it is closed under scalar multiplication and it is closed under uh, addition. So whenever these two properties are whole, then we say that it is a subspace. So determine a subspace. Which of the following subsets is a subspace in R3? So there are two questions. W is equal to x1, x2, 1. x1, x2 belongs to R. So let's see. So for this question number 1, let's see. So for x1, x2, let us take any variable. So we will choose 0, 0, or you can choose anything. So let us we choose as 0, 0, and 1 is fixed here. So we write 1 here and belongs to W. Let us we assume this. So for the subspace, we will show we will show the two property, addition and scalar multiplication. So let us check the second property, that is if we multiply any scalar with that vector, that would be is equal to 0, 0, minus 1. So it is not belongs to W because of minus 1 is not belongs to W. So we say that it is not a subspace. So similarly for question number 2, it says that W is equal to x. There are three vectors, 1 and the second and the 3 tuples are there. So let us check. We see again v1 plus v2 and v3, and there is another, we take u1 plus u3 and u3. So we take two vectors, and again we will check the two properties of the subspace. Property number 1, addition, v plus u. If we are going to add, we will get first and the second and the third. So again this belongs to the vector space. Similarly, let us we check the second property. The second property is if you multiply any constant with that vector, any kv1 plus kv3 and kv3, and this is the third. So again this belongs to W. So W is a subspace in R3. So these are the normal thing. Intersection of two subspaces is a subspace. This is a theorem. It says that if V and W are both the subspaces of the vector space U, then the intersection of V and W denoted by V intersection W intersection U is also a subspace of U. So this is a theorem. So the next thing is linear combination. So a vector V in a vector space V is called a linear combination of U1, U2, U3 in V if V can be written in the form of V is equal to C1, U1, C2, U2, Cn, where C1, C2, C3, Cn are called the scalars. So these are called the linear combinations. So find the linear combination. The question is find the linear combination of V1, V2, V3. So let us take proof. W is first we have to prove that 111 is a linear combination of V1, V2, V3. So first of all, we write for the linear combination, we have to write, we know from the formula for a linear combination, we have to write W is equal to C1, V1, C2, V2, C3, V3. It is a formula of linear combination. So we have to show that W is equal to 1111 is a linear combination. So we write 1111 is equal to C1 V1. It is V1. Here we write C2 V2. I write here C3 V3. This is I write C1 V1, C2 V2, C3 V3. Now open the bracket. So I write C1 yani C1 multiply yani C1 plus C2 into 0 plus C3 into minus 1. So I write C1 minus C3 here, just adding all them. Then 2C1, then 1C2, then 0C3. So I write 2C1 and C2. Similarly for the C3, I write C3, 3C1 and 2C2 and 1C3. So I write these things here. So it is the complete, our left hand side will be 1, 1, 1, and the right hand side is whatever the thing. Now compare the coefficient. So C1 V1 is equal to 1. So I write C1 minus C3 will be equal to 1. Secondly, it is written here 2C1 plus C2 will be equal to 1. 2C1 plus C2 is equal to 1. So I write here. Similarly, last one is C3 3C1 plus 2C2 will be equal to C3. So I write that one is the right hand side. Now we have three equations and three unknown, C1, C2, C3, and three equations, equation number 1 and 1, 2 and 3. We can solve these three equations with either by the equation or we can solve by the Gauss elimination, Gauss-Jordan method. So when you are trying to solve these things, you will get the value these like this. You will get this type of solution. If you remember, whenever your last row will be 0 whole, then it means that you have infinitely many solutions are there. If your last row whole will be 0, it means you have, so your solution will be C1 is equal to 1 plus T, C2 is equal to 1 minus 2T, and C3 is equal to T. So put different value of T, you will get different solutions. So if you put T is equal to 1, if you put T is equal to 1, you will get W is equal to 2V1 minus T. T means there are infinitely many, as I told you in my week 3, if we have something on the right side, if we have something on the right side and left side is 0, then we say that it is no solution. If we have left side is again, if something is written, then we say that it is a unique solution. If we have total row will be 0, then we say that it is infinitely many solutions. So when we have infinitely many solutions, so we say that there is a T, or you can say there is a T, P, Q, anything you can else. Infinitely many solutions means When you put t is equal to 1, there is one solution. When you put t is equal to 2, there is another solution. When you put t is equal to 3, there is another solution. When you put t is equal to 4, there is another solution. So it means there are infinitely many solutions. When you change the value of t, you will get different solutions. So that is why we put the value here t. That is why we put t. Okay, understand? So here it says that when I put t is equal to 1, so you will get this solution 2v1 minus 3v2 plus v3. So this is the solution. So for more detail, I will explain these things in the next week. So you will concentrate. The lecture is over up to here. So for dot product and cross product, you will see, I will define on my face-to-face class. You will see on the book also. So if you have any question, then ask me. Okay, so try to solve these assignments and try to submit these assignments on time. And after the deadline, I will give you the solutions of the assignments so that you can understand where is your mistake. So to now it's over. So just tell me. Yes, the due date will be 28th. If you submit, I will post the one message. If you send the assignment after the deadline, we will give you only 10% of the marks, and we will give you 2 marks of the assignments. So I will post you the announcement maybe today evening regarding the late submission. So there is no late submission. If you submit on the late, then your marks will be deducted. So okay, have a nice day. And there are many sections. So you will see the syllabus is on the blackboard. When you see the syllabus, there are so many columns are there. There are study notes and something are there. So the syllabus is given there. You will see the syllabus. After watching the syllabus, then concentrate on the book. So everything is defined on the syllabus. Okay, good night and have a nice day.
Recording stopped.